Hey everyone, so today I want to talk about system design for Dropbox. And before I get started, the usual disclaimer. This particular system design is inspired by this particular article and the relevant video. So I've been using Hello Interview to brush up my system design and data structure skills, and this particular video is a product of that upskill. So without further ado, let's get started. So let me start Dropbox system design. Now, in order to get started, we will need to define what are our functional and non-functional requirements. The first is functional requirements, which are user should be able to upload files from any device. User should be able to download files from any device. And the third is user should be able to share files with other users. There are some out of scope requirements as well. First is no online editing or viewing functionality. Yeah, pretty much it. Then we will have some non-functional requirements as well. The first is upload large files, let's say of the order of 50 GB. This can be 100 GB as well. The design will support that functionality. The second is resumable uploads. For example, if my system or my network breaks down in the middle of an upload, I should be able to restart from where I left. I should not be forced to upload 49 GBs again if there was a network issue or whatever kind of issue at the 49th GB upload. What else? We will have to talk about security. The system should be secure. By system we mean files. And when we talk about CAP theorem, this is a highly available system. Eventual consistency works in all the cases. It is fine if I upload a file in India and it is not visible to a user in, let's say, Australia for a while. So eventual consistency is fine, and we will go for high availability. Let's talk about some out of scope non-functional requirements as well. The first is a limit on user storage, something like premium system. Right now Google Drive supports by default 15 GB of upload, and after that you have to purchase storage. So similar kind of functionality is not supported in the system. Second is, let's say, security, in the sense like check for viruses, etc. We can have a couple of additional non-functional requirements. For example, fast upload or download. This would be as fast as, so something like as possible. Okay, what else? Cool. These are our requirements. Now let's start with our core entities, and these are not going to be full-fledged table schemas. The entities will correspond to a table, but the schema part will come to later, as in when we go into deep dives or a high-level design. So with that thing, there would be 3 or 4 core entities. One would be the user, obviously, who is uploading the file and with whom the files are shared. Second would be file. Third would be file metadata. What exactly are the details of the file? What is the size? Who uploaded it? At what time? Where it was created? So on and so forth. These are our core entities, and then we will have some APIs as well to support them. So the first would be to support the functional requirement. So the first requirement is we should be able to upload a file. This means there will be a post request on slash files, and this can return 200 OK that the file was uploaded. We would be sending a couple of details in the params. For example, we'll be sending file metadata. And there's one thing to note here, and let me actually just write it, that we are not sending the credentials of the user. We are not sending user ID in the API response request as well itself. And the reason for that is to avoid any kind of security breach, any kind of hacking. If some hacker, if some unknown, if some entity, if some person gets hold of the user ID of a particular user, then this user could be impersonated by these people. So we do not want to go into that kind of a scenario, and for that what we do is we use something known as JWT token or session token for authentication or authorization. A lot of login functionalities like AWS Cognito supports this out of the box. So yeah, that's what we're going to do. So now first, your functional requirement is satisfied. We should be able to now download the files from your device, and for this we would have a GET request which will be files, and then we will need to pass the file ID. This will return the file which is being requested, and obviously file metadata. So there would be two objects which are being returned here. The third is we should be able to share our files with other users, and for that we can do a patch request on the same resource. So files, and then in the params we'll have file ID and then user ID, and then we can have action as well. So we can share a file, and then we can also unshare a file. We can remove the access. So that's why we have an action parameter here, which is, let's say, action is share, unshare, something like that. I mean, we can obviously always debate about the verbs, the nomenclature, but for this works. Okay. Now with all these things out of the picture, we can move on to our high level design, and that's what I'm going to do now. So we have, one second. Okay, so okay, that's fine. So we have a client, and this could be a web browser, a client on the machine. For example, Dropbox has a Mac client, a Windows client. I'm not sure if there's a Linux client or not, but so we and also it can support a browser. So the client could be anything with which the user interacts, and the client will make a request to something known as AWS API gateway. This will take care of a lot of things for us. It takes care of routing, it takes care of authentication, it takes care of it takes care of rate limiting, and so on and so forth. So it also works as a load balancer. So that is another thing which I want to talk about, mention here. Load balance. Okay. So a client makes a post request on files, and what happens in turn is that we will have a file service. This is our file service, So we'll have a file service, and then there would be a database to store the metadata for this particular file. So this is our metadata DB. This will have some fees like so file metadata. This would be user ID, who is the owner, then we will have file ID, then we'll have created at, then we'll have uploaded at, and then there will be some other data as well. Now the question is, how are we going to store the file? The first solution is, we can store the file on the server itself, which is not optimal, which is not great solution, because what happens if the server goes down? That is a problem. We have this kind of, a place where a single point of failure basically. We will not be able to retrieve that file as and when the user requests it. Of course, it will be stored on hard disk, so it will be persistent, but a bit problematic. The other way to do that is use a blob storage, something like S3, AWS S3, because we are in AWS ecosystem we are talking about. But of course, there are other cloud providers, other blob storage systems solutions available. So we have this AWS S3, and the way we can do is, first of all, we upload a file through our file service server, and the file service server uploads that data to Amazon S3. Now the problem here is that it is again not efficient. We are uploading the files twice, so not a great solution. What we can do is we can use something known as pre-signed URLs. So let me talk about that somewhere. So what are pre-signed URLs? Pre-signed URLs are functionality provided by cloud providers to upload files directly to blob storage. I'm not sure what the name is in other cloud solutions like Azure or GCP, but I'm sure a similar functionality exists. Now what that means, through this functionality, through this signed URLs, you can upload the files directly to a specific bucket in AWS ecosystem. How do you get those pre-signed URLs? With respect to AWS, the SDKs provide you with the functionality to create a signed URL and return it back to the user. Other thing about signed URLs is that, one, they are authenticated, so only specific users, specific keys, authentication keys, access keys can create these signed URLs for a particular bucket. And also they are short-lived. You can define the limit of the validity of these URLs. So for example, you want this URL to be valid for, let's say, 5 minutes or 7 minutes or 10 minutes or even an hour for large number of files. So you can specify those particular details in the signed URL while creating the signed URL, and the signed URL will be available, would be active for that, will be valid for that particular amount of time. After that, it will go kaput. It will not be, it will not work at all. So time bound temporary access to bucket, storage bucket, without giving access to the whole bucket. So these are the good things about your pre-signed URLs. That is why we are going to use pre-signed URL. And the way to do it will be like our file service will have a functionality which will create the which will create the pre-signed URLs, and then it will return back to the user, and then the client will directly call those signed URLs to upload the files to S3. So let me update the diagram. So this will be get pre-signed URL, and Okay, got it. Now a client makes a request to file service. It gets the pre-signed URL. Obviously, it uploads the data to metadata database, and then once the client has the pre-signed URL, it can make a call to this guy. Okay. Upload files. Yeah, upload file. Okay. Now there is one thing. How does our file metadata, this database, know if the file has been uploaded or not? It is possible that we have uploaded we have created an entry in this metadata database, but for whatever reason we did not, or we were not able to upload the file. So in that particular case, this particular metadata database will be out of sync with the reality. So we need to have some kind of functionality, some kind of field to denote whether the file exists or not, and that particular field could be status. So you have a status which is what, either uploading or uploaded or pending. It could be pending as well. Now again, the next question is how we are going to make sure, or how we are going to update the status of this status field. And one simple way to do that is through our client. Once the file has been uploaded, we can make another request which will update this particular field here, and that's a valid solution. But then the responsibility of updating this field resides with the client, and it can fail sometimes. For example, what happens if the client himself or herself makes this malicious update? Very unlikely, but it is possible, though it will not serve any purpose. But also it is possible that the client just runs out of power or whatever the moment it is able to upload these files to S3, and as it was about to make a request here to update the status, they lost something. There was some corruption. So to care for such situations, what we can do is use S3. So there is something by the name S3 events, which will notify our file service after a file has been uploaded successfully, that the file has been uploaded, and then the file service itself can make an update to the database. So let's do that. Let me change the status of the direction of these arrows. That is point number 1, and we need to make one more S3. We need to make one more update, which is the S3 link. How will this particular file metadata database know that exactly where the file resides? So we need to have an S3 link as well. Okay, S3 URL. So let's just okay, so the first requirement is done. The next requirement is that you should be able to download the files from any device, and again we can go through the same route that the client makes a GET request to file service, and the file service first of all downloads that file from S3 to file service, and then it returns back to the user. But there's no point in doing that. We can use the same pre-signed URLs to retrieve files as well to the user directly from S3 to the client's machine. So that's what we are going to do. We have a get files and with this file ID. So what will happen is your client will make a request, get request here. The file service will look into metadata database, and we have not talked about what database will this look like. Just give me a minute, I'll come back to that. But the file service will look into metadata database. It will figure out what exactly is the S3 URL for that file. It will wrap it around a pre-signed URL, and it will return back that URL to the client. And then the client will download the file from AWS S3 directly without having that file downloaded on the file service server and then returned back through the API gateway route. So that takes care of our file downloading file request as well. And now going back to what kind of database will this metadata file metadata will be. It could be any database. It could be SQL, NoSQL. Because there are not a lot of relational entities right now, I'm going with Dynamo database. But I mean, to be honest, any database would work here. We can go for a SQL Postgres database as well. That will not break anything. The third functional requirement is that we should be able to share files with the user, and this would be a patch request. So let me. Yeah, and this is something. There are a couple of solutions here as well. What we can do is we can have mapping inside this particular database, like who are the users which have access to this. So access, and then we can have user one or whatever you want to have, and then it could be write access, it could be user to read access, and so forth. And then of course you can structure the this JSON accordingly the way you want to do it. But this particular approach is not great. The reason is that when as a user I open my home page, so as to speak, on Dropbox, I get to see all the files which I have access to, whether they are uploaded by me or whether they have been shared with me by other users. So now in this particular use case, I will have to scan all the files, check if this particular user has access to that file or not, and then display that file if that user has access to that file. Very time consuming, not at all efficient. So what we can do is we can just remove this particular mapping from here and take it to another table. And for that, I think I will go back again. I can use the Dynamo database itself, but because there is no specific reason why I should be using Dynamo database, I will go with Postgres. So Postgres is just, because we have one relational mapping here, it makes a better use for this kind of mapping. But again, no particular reason why we cannot use Dynamo database for the same functionality. So we have a file mapping table, and then this will have the user ID, which is your primary key, and then you will have a file ID, which is your foreign key. Okay, so this is how we can share the file with other users as well. And with this, our functional requirements are done. We can now move on to our non-functional requirements, which are these 5. And I think because I have practiced this particular system design offline as well, I know that some of the requirements would be resolved simultaneously. We'll have this one solution that will take care of both the requirements. Cool. So upload large files. Let's just talk about this one first. Now there are a couple of problems why we cannot use this approach, the current approach, to upload these large files. One, if we are thinking about one single HTTP or HTTPS request, most likely HTTP I suppose, this particular upload of file of bigger size will not pass through. There are a couple of reasons. One is that the browser itself will have a limit. It will not allow you to upload a payload which is more than a couple of 100 MBs. Then there are network limits as well. The gateways will make that limitation. So in order to upload these large files, what we can do is we can use something known as chunking. So let me write it down here. Upload large files we can make use of a feature technique by the name chunking. And what is chunking? Chunking is basically dividing a large file into small parts of, let's say, 5 MB, 10 MB each, and then uploading all those files in parallel and sequentially, depending upon the bandwidth, to your S3. And then at S3, once all the files are uploaded, you can combine them, you can club them, and you have the entire 50, 100, 200 GB file uploaded on your stored in your S3. Now, a couple of things there. One, how do we do this chunking? And second, how do we know which particular chunk has been uploaded or not? So let me answer the second question first. What we can do is, when we are uploading the file metadata itself, we can have another field here which is chunks. Okay, and this will be some kind of a JSON array, and it will have fields like let's say chunk ID 1, status, and let's say this is uploading, all of it is uploaded. Then we will have another so this is enough. So we have chunk ID 2, which is in progress, so it is uploading, and then we have chunk ID 3, which is pending, something like that. So in this way, we can upload chunks one by one or parallel, depending upon, we'll come to that. We can upload chunks, and we can define what exactly is the status of those chunks. So this is one part, and then we will have one status for the entire file. What exactly, where is this file is uploading or uploaded or pending. That is point number one. Now the question is, what happens now? We have a thing which is resumable uploads as well. Okay, sorry, before that, now how are we going to exactly allow this? So there is something known as, again I'm talking about AWS S3 ecosystem, there is something known as multi-part upload, which is out of the box solution for such scenarios. Okay, so the way multi-part upload works is that, by the way, multi-part reminds me of another metadata, which is MIME type. So you would want to have what exactly is the type of this particular file, whether that is text file or JPEG file or media file or any other kind of file. So that would also be a part of the file metadata. I forgot about that earlier. Anyway, so multi-part upload works in a way that, you have an API request, you give the size, while asking for pre-signed URLs, you give the size of that particular file back to the user. Again, this will have this particular metadata as well. Yeah, the SDK will help you to chunk the files, and then you can upload the files one by one through the pre-signed URLs. At the backend, once all the files are uploaded, once all the chunks are uploaded, you have to send a particular message on S3 through SD SDK, which tells you that that particular file has been uploaded, so that S3 can combine all those chunks and create one single file. Without sending that particular message, the end of file kind of message, S3 will not club all those files. So we'll have to look into what exactly that message, what exactly that parameter is. But there is one such parameter. This is something I read in the documentation for S3 for multi-part upload. So we will have n number of S3 pre-signed URLs given by the S3 SDK, and that is how the multi-part upload works. Now there is another problem. The problem is that let's say, as I am uploading a particular file in the chunks, I lose power, my machine went down, or there was my network provider was had a breakage, and my file upload failed because of some network issues. But at the same time, some of the chunks have been uploaded. Now the question is when I come back online, how do I know that some chunks have been uploaded, some chunks have not been uploaded, which other chunks are uploaded, which are not uploaded, and then resume the file upload. So the way to do is we use something known as fingerprinting, and fingerprinting is nothing but just a mathematical function which creates a unique hash for each file. We can think about using the file name itself, but again, not the best approach. The user might have same names given to the two different files or different size, and that is not a good way to differentiate between different files. So we will use this fingerprinting technique, and use fingerprinting to identify chunks and a file. So there would be we will be doing fingerprintings at two levels, one at the file level, which will so the fingerprint, by the way, depends upon the contents of the file. If there is any change in the contents, a new fingerprint will be generated. Let's say there's a huge file of 100 GB, it's a text file, and I change some characters in the last 10 lines. So the fingerprint of both these files will be different, and that's how we are going to identify. However, so we will be using this fingerprinting at the file level and at the chunk level as well. Now when I am resuming a file upload, I will make a so we'll have a fingerprint column here as well. So there is a fingerprint, and then fingerprint column would be in all of these. Fingerprint column would be in all of these things as well. Now, whenever I'm resuming a file upload, the file is 45 GB. I will calculate fingerprint at the client level, and I will see if such a fingerprint exists in the file metadata. If it exists, then I will figure out, the system will figure out which chunks have been uploaded, which have not, through again the fingerprint for all those small chunks, and the chunks which are uploaded will be marked as uploaded, and the chunks which are not uploaded will start uploading. Of course, we will use the status column as well to figure out if that particular chunk has been uploaded, but we'll do a check again in this particular case. Cool. So this takes care of two of our requirements. One is the resumable uploads, and the third is large files. So I'll mark this as done. I'll mark this as done. Now let's talk about fast upload and download, and the way we can do this Now for fast upload and download, what we can do is we can use compression techniques, but we have to be smart about it. We can think about compressing the files at the front end, the chunk at the front end, and then decompress them at the back end. However, we should be mindful about for which particular file types are we going to compress. For example, a text file can be compressed. There would be a lot of gain when we use any of the compression algorithms. We will be able to reduce the size of the file. But if we are thinking about compressing a file, which is, let's say, a JPEG file or a media file, the ROI over that compression is very less. The codecs are already the most optimal, so the gain would be very less, and we would be spending a lot of time in compression. So for such files, there is no point in compressing the file at the front end. So we can have that kind of selective logic where we decide which files have to be uploaded, which files have to be compressed and which files not. So that is about fast upload and download as well. Similarly, we can compression depending upon file type. So what was I saying? Yeah, so we'll do the same functionality, same trick on the download part as well. We'll check if a particular file, if there is a lot to be gained uh, while compressing a file. In compressing a file while downloading, if there is, then we'll download the file, we'll compress the file and give it back to the user. If not, then we'll give it as it is. Cool. So now the third part is security, and there are a couple of things here again. So we will have security on. We'll be uploading the files through HTTPS. So that is security, ensuring security, secure upload. So use HTTPS while uploading, downloading. This will encrypt the file during upload and download. So that takes care of the during the flight, on the flight security concerns. Then pre-signed URLs are also they also enable secure file transfer. For example, what happens if some unauthorized user gets access to my particular link. So the one thing about these pre-signed URLs is that, as I mentioned earlier, they are short-lived. You can configure whether those links are to be have to live for 5 minutes, 10 minutes, 15 minutes, whatever. So after that particular time has elapsed, even if that particular link is found by some other user who should not be getting that, we can they will not be able to get it. The other thing we can do is we can ensure that those particular links are valid only for certain IPs. So let's say you are working in a big in a place where you have purchased some static IPs, and the users access the network only, are supposed to access the network only through those particular IP addresses, those particular VPNs. So now we can configure our S3 pre-signed URLs to be available to be working only in these particular, only for these particular IPs. If any other IP is hitting, if any user is hitting the pre-signed URL apart from these IPs, they could be denied, and that way so restrict access to specific IPs through pre-signed URLs. Okay, and the third is you can also enable S3 encryption. So this will just improve your chances of the security. So yeah, now we have done the this part as well. Cool. I think that was all about this Dropbox design. This is not a very complicated system design, comparatively easy, and that is why we have completed it in, I don't know whatever the length of the video. Let me just check if I missed anything in the design. Let's go through this once again. So we have these core requirements: edit files, view files without downloading them. Okay, highly available, large files, secure and reliable, as fast as possible. Okay, so this is good. Core entities are these three. APIs are post files, get file, and here he has used post. I have used patch on the same file itself. High level design is okay, MIME type, size, which I forgot, which I added later. Single server, blob storage, upload file directly to blob storage. We have pre-signed URL thing. Okay, download files through file server, blob storage, interactive CDN. I did not talk about CDN because I found it a bit unhelpful. CDN works great when you know that a particular file would be downloaded multiple times in a particular geography or wherever, but we do not know if that is going to be the case. If a file is shared between just two users and user B downloads the file at in a different location, then storing that file in CDN makes no sense because CDN is also costly. So that is why I not use CDN. It is okay if the user is downloading the file a bit slowly, but it works. Okay, and we have tried to handle this in other cases like what's that, compression kind of thing. Now share files, again I have not talked about caching to speed because it did not make sense to me. Why would I cache that data if I can just normalize the data? And it is, it's not a very complex solution. We can always think about just removing that particular table, removing the data from that table to a different table. So I did not find the need to go to or to talk about this particular solution. So this is our system. We have a CDN which he has a CDN which I did not have. We have a API, load balancer, download, upload, S3, metadata database. Okay, great. Oops. Okay. Now we have potential deep dives, support large files, progress indicator, resume uploads. I did not talk about progress indicator, but yes, that can come. That will play a part. So we have timeouts, browser limitation, network interruption user experience. Okay, so these are the reasons why a single post request will not work. By the way, I talked about a couple of these. So yeah, chunking. Here we have chunking. S3 is a common solution here. 5 to 10 MB pieces. So we have different chunks here, chunk status, and now we talk about event notification, which is something I think, yeah, I talked about earlier itself. We have fingerprinting here, mathematical function to generate unique hash. Okay, great. This is to figure out if the file, the chunk has been already uploaded or not. Okay, multi-part upload. Okay, so yeah, the client breaks the file into parts and uploads each part to S3. S3 combined into single object. We have different SDKs here. Okay, so we have explained that as well. Make uploads and download as fast as possible. We are talking about compression, and here he talks about whether you should be compressing a file in the first place or not. There are pros and cons. There are some costs which I mentioned earlier. So great. We have different compression algorithms. We could have choose any. We can choose any. And file security, encryption transit, encryption at rest, access control, which is provided by our shared list. Cool. We have what happens if unauthorized user shares the download link. Authorized user share the download unauthorized user. We have taken care of that as well. The URL is short-lived. And then we can work in modern CDNs to ensure that it is valid. So cool. We have covered all the parts of the system design, and I can close the video right now. Awesome, cool. Thanks guys for watching this. Bye bye.